my screen on? There it goes. All right. Here's the first picture. I'll check that one. We got next work today. So that first one, remember, if it's odd, we want to be able to turn it upside down and it look the same. That one's a little harder to visualize than the even one we looked at yesterday. Okay, and then number 2, the point that would also be on the graph because it has symmetry to the y-axis. I tried to just give you a rough sketch there, is -3, -18. Number 3 is a neither. I did the little proof there. If I plug in -x, it does not equal the same as the original function or the opposite. And then at the bottom, number 4 is false. And I just, when it says counterexample, just give an example that shows how that statement could be false. So there's an example of a function that's symmetric to the y-axis, therefore even, but it doesn't go through the origin. But lots of different things you could have given for that one. B is true if the polynomial is in standard form. So if I gave you like x to the 4th plus 2x squared, all even powers, it's all FOILed out, it's even. But if it's not all FOILed out, like x minus 1 squared, you can't say that, okay? So if I FOILed that out, it'd be x squared minus 2x plus 1. That's not all even powers, okay? So you have to make sure it's all FOILed out in order to answer that. Now, if I change that last question and said if it's all odd powers, it's odd, that is for sure not true. Like number 3 is an example of that. Number 3 has all odd powers, but it is not odd. Okay, and we saw one in the fraction problems we did yesterday. All odd powers, but not odd. So you want to be careful making rules about what kind of exponents you see. Those can get tricky. All right, any questions from yesterday about increasing, decreasing constant, mins, maxes? What else? Yeah. Because of the 3, yes, that plus 3 at the end. If that wasn't there, then it would be the opposite of the original function and it would be odd. Yep. Okay, other questions from yesterday? All right, so we just got to finish up 2.5 today. And you've got a handout. We're going to talk about rates of change today. Okay, so rate of change definition. We're going to start with that. I'm going to give you the formal definition, and then I'm going to give you the shortcut formula. Okay, so it is f of b minus f of a all over b minus a. Okay, and that is where x changes from a to b. Okay, so that's our formal formula explanation. Okay, what that means, rate of change means average slope. Okay, we can't say just strictly slope because now when we talk about all these kinds of different functions, we're going to have curves. Curves are not a constant slope. Only a line has a constant slope. So if we have something that is a curve, we calculate between 2 points on average what the slope is going to be. That formula that you see there, it says x is changing from a to b, which means our denominators are x values. Okay, that's what a and b are. And our numerator, when I plug an x into the function, don't I get a y out? So that's all that's saying. It's the y's that go with those x's. Do you recognize that? it's just our slope formula. Okay, so it's going to look like function notation, but it's your slope formula in disguise. You just need to remember it's on average what the slope is. So if it's a positive, it just means the graph is increasing. If it's a negative, it means the graph is decreasing between those 2 points. And if it's 0, it means the graph is staying the same between those 2 points, but not necessarily at a constant rate. Okay, so we're going to do the problems on the front first. It says for each problem, find the average rate of change over the given interval. Okay, so when we have an interval, remember interval notation, these are both x's that you are given here. Okay, which means you have half of 2 points. Your first point is 0 something, and your second point is 3 something. Now, you actually have the graph and the equation here, so you could use either one to get the second half of the point. We might as well use the graph because we have it in front of us. So 0, what is a point on this graph? 0, 1. And 3, 7. Looks good. Okay, so I can find that there and there. Okay, if you didn't have the graph, you just plug those x values in to get the y's that go with them. Now, all we have to do is use our slope formula, y minus y over x minus x. So 7 minus 1 over 3 minus 0, I get 6 over 3, I get 2. So that tells me, say I draw a line between those 2 points. On average, if I follow that curve between the values of 0 and 3, it's increasing by approximately 2 units for every unit I go to the right, okay? It's not exactly that all the way across. Part of it, it's even decreasing a little bit, but it's on average, okay? All right, let's look at another one. Y equals -1 over x minus 2, and we're looking at it between the x values of -3 and -2. All right, so -3 something is a point on this graph, and -2 something is a point on this graph. Do you guys remember what that's called, that little dashed line that you see in the middle of this graph, by the way? No? I feel like you're kind of on the right track with your thought process with that, though. It starts with an A. Asymptote. It's an asymptote. It's a line that our graph's going to get really, really close to, but not touch. That's going to be important tomorrow. Okay, so -3, what do you think the x value is approximately there? Maybe it's like right here? Are we better off just to plug it into the equation maybe, so we have a better answer? Okay, so let's do that. If I plug -3 in for my x there, I'm going to have a -1. I'm going to put that negative on top over -5. -1 over -5 is going to give me 0.2 or 1/5. Yep, either one's fine because they're both exact. Okay, and now if I plug -2 in there, I'll have a -1 over a -4, which would be 1/4. Good? Okay. Y minus y over x minus x. And I'll use the decimals because we can just put them in our calculator then. So 1/4 is 0.25, minus 1/5 is 0.2, and then -2 minus -3. So on the bottom, I'm just going to get a 1. On the top, 0.25 minus 0.2 is going to give me 0.05 over 1, which is just 0.05, or as a fraction, that's 1/20th. Okay. We always want to make sure we give exact answers. I was able to use the decimals here because my decimals are exact. All right. And then if you connect those, remember that value is showing us what's happening between those 2 points. It's increasing by a rate of about 0.05. It's increasing because it's positive, but it's a pretty small slope there that we have on that part of the graph. Okay, questions? All right, so now these couple at the bottom, I'm going to let you guys try 3 and 4. Remember, we don't have the graph now. You're just using the points. We have x's. Your job is to get the y's that go with these x's and then find the slope between those points using our average rate of change formula. Okay, slope formula. Go ahead, see if you can do these 2, 3 and 4. Okay. One more minute and then I'll put the answers up on the board for you. Ready? Okay. Ooh, there goes. All right, so for the first one, the y values that I got are 5 and 2.5. Plug them in, simplify your numerator, simplify your denominator, divide last, I got -5. And then I went ahead and just added the fact that that tells me that that graph is decreasing at least between those two x values because I got a negative slope, okay? Oh, I see a lot of erasing. Uh-oh. Did I do something wrong? No, fast. Okay, you're scaring me right now. All right, and then for the second one, I plug in -1, I get out -1. I plug in -0.5, I get out -2/3. And then you can just be really careful with your calculator stuff there. My positive slope, so that tells me it's increasing between those two numbers. That's all we're doing. Just put an x in the equation to get the y to go. Yep. Okay, so it'll never say slope in the problems. It'll say find the average rate of change between these 2 points. You just need to know that that means slope. Yes. I just plugged in my calculator. And that's my CV. Yeah, I think we're good. You might have got a different answer there if you didn't put the -0.5 in parentheses. Both sides. Okay. Any other questions on 3 or 4? Calculating average rate of change. Okay, let's do the last one of these at the bottom then. It says, find the average rate of change for the function 1 minus 3x as x changes from 2 to a. So this one, we have a starting x value, but the ending x value could be anything. So we're just going to use an a. So starts out the same way. My 2 points. My first point has an x coordinate of 2. My second coordinate has an x coordinate of a. All right, if you plug 2 into this equation, what are we going to get out? 1 minus 3 times 2. What do we get? We're going to get -5, okay? If I plug a in for x, I actually can't simplify anything. I just replace the a with x. So that looks like 1 minus 3a. That's all I can do. Now we're going to use our slope formula. Okay, so y minus y over x minus x. 1 minus 3a minus -5 over a minus 2. Okay, so now I have 1 minus -5, that's just going to be 6, minus a negative is plus, minus 3a all over a minus 2. I can simplify this further. What do the 2 terms in the numerator have in common? I'm going to take a 3 out. And actually, better than that, I'm going to take a -3 out. And I'll show you why in a second. If I take -3 out of the first term, what am I left with? -2. And if I take -3 out of the second term, I'm left with positive a. And the denominator is a minus 2. Are those the same thing? A minus 2 and -2 plus a? Those are the same. And it's a factor. It's multiplied in the numerator, so I can cancel it. So that's why I took the negative out, so my -2 and my a matched what I had in the denominator. If you didn't see that at the beginning, you could just take it out in the next step. So the answer is -3. It doesn't matter what the a value is. And here's why. This is the equation of what? Well, nothing squared. It's a line. And isn't the number in front of my x the slope? And isn't that the answer we just got? It shouldn't matter what 2 points I pick on this line. Because it's a line, the slope is always -3 between any 2 points that I pick. So that's why this happens. Okay, so if you see it's a line, your answer for rate of change is whatever the slope of that line is. You can save yourself all this work. Okay, questions? Flip it over. All right, see if you and your partner can talk about number 6. See if you can answer that question. With or without a rate of change formula, I don't care. It applies to rate of change, but see if you can answer it. Go ahead. All right, what do you think? Did he break the law? Yes. Okay, so if we want to talk about like mathematical formulas relating this to rate of change, when you drive, it's miles per hour, right? Miles per hour. Okay, so if I'm writing a rate of change formula, it's the difference in the miles. So at 1 mile he was 30 and or 31 miles and the other one was 0. So he passed the police and then he went 31 miles down the road further, okay? How many hours have passed? You need to find the difference between 6:30 p.m. and 6 p.m., which the difference between the two when you subtract them is a half an hour. That's really what's important, right? I mean, you can write those numbers however you want. But what has changed? His distance, his total miles traveled in that period of time is 31. And his time is divided by 0.5, half an hour, per half hour. If you divide those, you end up getting 62 miles per hour is the rate that he's traveling on average. Maybe slowed down, sped up at some point during there, but on average, he's traveling that fast, which is faster than the speed limit he broke the law. Okay? Questions? All right, cool. Last thing we need to add to 2.5 is the difference quotient, and we're going to put it on the little bubble at the top here. All right, difference quotient, for those of you that plan to move on to calculus next year, is going to be very, very important to you, okay? For right now, for us, it's just going to be like an interesting thing that we could do with function notation that relates to our rate of changes. But you'll talk about like the context of it and stuff in calculus a whole lot more. Here's the formula. F of x plus h minus f of x all over h. Okay. In words, what we are doing with this formula, we are plugging x plus h in the equation, and simplifying in that first little notation. The second thing we are doing is subtracting the original equation. That's what the minus f of x means. And then the third thing we are doing is dividing everything by h. And if you are doing this problem right, h's should cancel. Okay, so that's how we'll know we're on the right track. Okay, so these are kind of like your 3 steps to calculate a difference quotient. Plug x plus h in and simplify. Subtract the original function. Divide everything by h. All right, then we're going to do these problems together. Give you a second to finish writing that down if you need to. All right. Let's try one. Find the difference quotient for g of x equals negative 6x plus 4. All right. So first thing I'm going to do is plug x plus h into my function. Okay, so taking the x out, x plus h in its place. We've done that before. We just make sure we use parentheses, like so. And then what can I do to simplify that? Can I simplify that? Distribute, yep. Negative 6x minus 6h plus 4. Okay, so in the formula, that's that whole piece, that f of x plus h, we just calculated it. So now I'm going to set up my big fraction, okay? What we just calculated goes first. Then we subtract the original function and put it in parentheses because you're going to have to distribute a negative. The original function is negative 6x plus 4. Then we divide the whole thing by h. And now we simplify. The only thing I'm going to do is distribute my negative through in the first step. Negative 6x minus 6h plus 4 plus 6h minus 4. And everything's over h. What happens in that numerator? Yeah, so the negative 6x's end up canceling, one positive, one negative, and then positive 4 and negative 4 end up canceling. If you're doing this right, anything that was in the original function in that parentheses should cancel, okay? So I get negative 6h over h, which simplifies to what? Negative 6, final answer. What is negative 6 on that line? It's a line. It's a slope. Difference quotient calculates the average rate of change between any 2 points on a function. And in a line, we get a nice pretty whole number. It's whatever the slope is. Okay? Now we're going to do it with some more complicated functions, like a quadratic function. All right, so we're going to start the same way. Now this is function h, which gets a little, I don't actually like that. Let's put a j there instead, just so it's not all the same thing. That can get confusing. All right, so let's find j of x plus h. So I'm going to plug x plus h into the equation for x. That'll just look like x plus h squared minus 3. Simplify it. What do I have to do to simplify that? FOIL. Square it by foiling. Yep. So what's my first term going to be? X squared. Outside and inside are both going to be an xh. So if I put those together, 2xh. Last term, h squared minus 3. Okay, that's all we can do to simplify it. All right, now let's put it in the big fraction. That's going to be first x squared plus 2xh plus h squared minus 3. Okay. Minus the original function. So minus my original function in parentheses, x squared minus 3, the whole thing divided by h. And then we simplify. What's the first thing I should do to simplify? Distribute the negative. X squared plus 2xh plus h squared minus 3 minus x squared plus 3. It's going to change all those signs. Divided by h. Then what? What cancels? Something should cancel. 3's cancel. X squareds cancel. So I'm left with 2xh plus h squared divided by h. Every term in that fraction has what in it? H, which means you can cancel one h from every term. We're reducing our fraction by h. So I'm left with 2x in the first term. I'm left with 1h in the second term. And my denominator, no h's, so I could put a 1 there, but usually we don't write that over 1. So this will be our answer. And then we just leave it like this. Again, it'll be, more applicable in calculus what you would do with that later, okay? All right, let's hop down to number 10. We're going to do that one together, and then I'll let you guys try 9 on your own in a minute. All right, find the difference quotient. Start with p of x plus h. All right, so 3 over x plus h. And there's literally nothing you can do with that. That's it. Okay, then plug it into the big fraction. 3 over x plus h minus my original function, which is just 3 over x, all divided by h. These ones, these rational ones where the x in the denominator, these are the easiest ones to set up because there's not really a whole lot you can simplify. They're the most difficult ones to simplify now because you got to think about like adding and subtracting fractions. What do we need to be able to do that? Common denominator, which I do not have right now. And I'm just looking at the numerator, okay? I have an x plus h and I have an x. So here's how I'm going to get my common denominator. In the first fraction, I'm going to multiply by x over x to get that x multiplied in the denominator that I need, okay? And you can multiply by whatever you want as long as it's something over itself because that's equal to 1. Doesn't change it. In this fraction, I'm going to multiply by x plus h over x plus h, okay? Again, to get a common denominator. And when you multiply fractions, we just multiply it straight across. Numerators together, denominators together. So in the first one, I'm going to have 3x In the denominator, I'm just going to leave it like this, x times x plus h. Okay. Minus 3x plus h all over x plus h all over h. So got a common denominator. Add them together, subtract them. Okay. So in the numerator, the whole thing's still going to be over h. When I put fractions together that have the same numerator or denominator, when I add or subtract them, the denominator does not change. It's still going to be x plus h. Okay. The only thing that's going to change is my numerator, and this negative is part of that 3. It's getting distributed in there. Okay. So I'm going to have a 3x, and I'm going to have a negative 3x. Aren't those just going to cancel? Okay. And then I'm going to have a negative 3h. Fractions divided by things are gross. So I'm going to rewrite this. I'm going to take that top fraction that I have, and instead of dividing by something, I'm going to make my life easier, and I'm going to multiply by the reciprocal. So instead of dividing by h, I can multiply by 1 over h. That's the same thing. And hopefully you're seeing right now, if I multiply these guys together, I'm going to have an h on top as a factor, and I'm going to have an h on the bottom as a factor. So what's going to happen with those h's? They're going to cancel. So I'm just going to cancel them now. Your final answer is negative 3 over x times x plus h. And that's it. Okay, those ones are tricky. That's why we did that one together. Okay, with your partner, see if you guys can do number 9. Okay, it's going to be pretty similar to number 8. You just have an extra term in there you got to worry about. Be careful with the foiling and distributing. Okay, I'll give you a few minutes. It'll be our last one for the day. How did I get the plus 2? From this plus 2h. Here, the h ends up canceling from that term.
Oh, yeah.
All right. What did you say, Preston? Good. And look like how impressive this looks. Like you could show somebody and be like, "Oh, I know how to do today." You do. You do. Have faith in yourself. We're getting there. I promise. Okay. All right. So the remainder of the period is yours. You can do the 2 problems with the exit ticket. We'll check these answers at the beginning of the period tomorrow. I'm going to come around and I'm going to ask you who you're working with. I'm going to give you your project habit for tomorrow. Tomorrow, all we're going to do is check this exit ticket and talk about the project. You're going to have time to work on it.